What secret holds New York together? It's not just steel or stone, it's a set of clever choices that turn a chaotic island into a surprisingly balanced machine. New York feels loud, vertical, and endlessly changeable. But beneath the neon and sandstone, there are quiet engineering stories. A thin copper lady standing on a gigantic concrete heart, bridges like woven ropes carrying neighborhoods, and skyscrapers that bend like tall trees in wind. Today we'll lift the veil and show the numbers that actually matter, and why they make this city feel alive. From the island's skyline to a single, iconic figure, connect the city's scale to the small, ingenious details that keep her upright. The Statue of Liberty is a lesson in lightness and patience. About 305 feet tall from bedrock to torch, but its outer skin is only a few millimeters thick copper, roughly like wearing a heavy coat made of pennies. Inside, Gustave Eiffel's wrought iron pylon works like an internal skeleton, channeling the statue's weight down into a 24,000-ton concrete foundation built inside Fort Wood. That foundation is why a delicate-looking figure can resist storms and millions of visitors climbing its 354 steps. Thermal expansion joints, especially in the arm, let the copper breathe as temperatures swing, so the skin doesn't buckle. Culturally, she's more than metal. The 7 rays on her crown are a visual shorthand for freedom reaching the globe. Stand beneath her on a bright day and you'll hear gulls, footsteps on the pedestal, and the soft rattle of wind, small forces that the engineers turned into design features. Shift from symbolic monuments to engineered ambition, from Liberty's statue to the steel needle that defined skyline ambition. When it opened in 1931, the Empire State Building solved a brutal urban problem: how to pack thousands of offices into a tiny Manhattan lot. Its trick was a steel frame, roughly 57,000 tons of steel, that rises through layers of limestone, brick, and window glass to reach a tip of about 1,450 feet. That steel skeleton moves the building's weight straight down through concrete piers anchored to bedrock, while the central core keeps elevators and stairs neatly stacked like the backbone of the city. Wind bracing and the building's mass combine so it can sway safely a few feet at the top during storms, like a tree flexing in wind. The observatories at 86th and 102nd floors aren't just views. They're platforms where engineering becomes theater. Inside, corridors smell faintly of old brass and polished stone, a reminder that efficiency and elegance were built together. From vertical towers to sweeping spans, let's cross from solid ground to cables that stitch boroughs together. The Brooklyn Bridge is a hybrid of masonry and modern cable magic. Its main span stretches almost half a kilometer, supported by 4 massive cables, each made from thousands of wires. The original spinning used over 20,000 kilometers of wire in total. Those granite towers, rising about 275 feet, act like cathedral buttresses, taking the deck's loads and sending them down into caisson foundations sunk into the riverbed. The roadway is a 2-level sandwich, cars below, a wooden pedestrian path above, so New Yorkers can look at Manhattan and feel the structure beneath their feet. The truss system under the deck stiffens the bridge against wind and traffic, preventing the deck from wobbling like a loose plank. This bridge wasn't just engineering, it was social infrastructure. It reconnected boroughs, boosted trade, and even became a promenade where street vendors and artists built a daily theater. If you're enjoying this journey, don't forget to like the video and subscribe to our channel for more city deep dives. From public spans to curated spaces, trade the open bridge breeze for vaulted museum halls full of gravity and light. The Met is a city inside a building, about 2.2 million square feet stitched together over more than a century of additions. Its Beaux Arts limestone facade hides a complex structural stew, masonry load-bearing walls, steel roof trusses, and Guastavino tiled vaults that look light but carry serious loads. The main hall soars into the 80-foot range, and the dome reaches roughly 95 feet, creating volumes that need careful load paths straight to bedrock. Skylights and glass roofs bring soft northern light into galleries, but require precise framing to avoid damaging fragile paintings. Walk through and you'll feel transitions, cool marble underfoot, muffled footsteps, and the sense that a 500,000 cubic foot mass of stone and steel is arranged to cradle art safely. The Met is engineering designed for silence. Now flip to the city's beating heart, from quiet galleries to LEDs, crowds, and the hum of movement at street level. Times Square is less a building and more a dynamic skin draped over a deep, complicated anatomy. Pedestrian plazas cover roughly 120,000 square feet and handle an astonishing daily flow, around 360,000 people, and similar numbers of vehicles moving through complex circulation patterns. The iconic LED arrays are supported by steel frameworks anchored to bedrock pilings. Some facades, like One Times Square, carry a 120-meter profile and a mast for the famous ball drop. Wind loads can be dramatic in the canyon of billboards, and engineers design for gusts over 80 mph striking large LED faces. Below, subway tunnels and utilities flow like the city's arteries. At night, the square feels like a mechanical carnival. Heat from screens, distant horns, and the constant click of cameras, all balanced by careful structural choices that keep the spectacle safe. New York's identity is an engineered balance. Lightweight skins on massive foundations, bridges that behave like musical strings, and museums that keep silence under enormous roofs. It's a city of improvisation made permanent through careful numbers and human decisions. Which city should we explore next, and which secret structure should we open up? Tell us in the comments, and if you loved this, share it with someone who thinks buildings are boring.